looking at the beginning of 3.1, dealing with the chain rule and how we can solve problems using something called a chain rule. This is a problem here first that we should be able to have solved finding a derivative given this problem. 2x plus 7 squared. Well, I could rewrite. I should always try to rewrite a problem first to make it look easier if I can. 2x plus 7 squared, just 2x plus 7 times itself, 2x plus 7. I could FOIL out. It would become 4x squared. I'd have plus 14x plus another 14x and then plus 49. That's a really easy simplification. So then I can now take my derivative properly and get 8x plus 28. Okay, not too difficult, right? Well, what if the problem though had said instead of 2x plus 7 to the second power, what if it was 2x plus 7 to the say the 200th power? Do you really want to go and expand out 200 times and then take a derivative? There has to be an easier way. So that's what we're going to go and look at here, is how we can make this work out a lot easier. It's with something called the chain rule, basically when you have functions inside of other functions. So the way we look at this is you have a composite function, an outside function and an inside function. We need to then be able to take the derivative of it. So the way we read this is it's the derivative of the outside. So derivative of the outside derivative of the outside. We say with respect to the inside, and then we'll multiply the whole thing by the derivative of the inside. So derivative of the outside, keep the inside the exact same, times derivative of the inside. Or some fun, clever people, do I die. Derivative outside, inside, derivative inside. Let's see if we can use it. Let's do that same exact first problem we had. If we have f of x equaling 2x plus 7 squared, that means f prime of x. The way we do this, we have to first identify what the inside and outside functions are. The outside function is something squared. So think of it as like x squared. How do I take the derivative of x squared? I'd bring the exponent in front, and now my exponent would be lowered by 1. So the derivative of the outside looks like that. The I, with respect to the inside, means keep the inside the exact same, and then times by derivative of the inside. Now, does that look the exact same as what we just did up here of, what was it, 8x plus 28 as our answer? Well, not really, but we can simplify this. I can multiply this 2 through, make it 4x plus 14, and we still have a times 2 at the end. So yes, that would become 8x plus 28. So that looks the exact same, which is great. So now if we wanted to, let's do this problem here, and let's even make it the same as what we said. Let's call it to the 200th power. And if I try to take that derivative, again, the outside function is something being raised to the 200th power. The way you take that derivative is 200, and it's now to the 199th power. That's the derivative of the outside. The inside stays the exact same, and then times derivative of the inside. You can leave it just like that. The way you would simplify this, I can't distribute into something that has an exponent. The only reason I can do it up here is because this exponent being 1 means, like, essentially there is no exponent up there for us to work with. So the only thing I can do, though, is I can multiply the 2 and the 200, because they're both numbers without exponents on them. So I can say 400 times 2x plus 7 all to the 199th. That's the way your multiple choice answer would end up looking. So let's look at a couple more examples to get us beyond just polynomials and solving some of these chain rule problems. So this first one very easily looks like it would just be an answer of e to the 3x. The derivative of any exponential is just itself, right? Well, not exactly. So your outside function would be e to the something. Your inside function, oh, it's not just to the x, it's to the 3x. So this e to the 3x is derivative of the outside with respect to the inside. The derivative of e is just itself, so that's why I kept e. You keep the inside the same. But the derivative of the inside still needs to be there as well, so we still need to multiply by 3. And the way they would write that, instead of times 3 at the end, the 3 would go here at the beginning. 3e to the 3x. Okay, let's look at number 4. 5 is just a number. It can stay put. Cosine is what we got to deal with. The derivative of cosine, which is the outside function. Here's your outside, here's your inside. Your outside function is cosine. Its derivative is negative sine. So now we'll say negative 5 sine. That's derivative of the outside with respect to the inside. So keep the inside the exact same. And now multiply by derivative of the inside. Negative 12x squared plus 14x. And there's your answer. You can keep it just like that. So, just to show it again. This is your derivative of the outside. Keep the inside the same. Derivative of the inside. This is your derivative of the outside. Keep the inside the same. Times the derivative of the inside. Do I die every time. Number 5. The cubed root of ln of x. Well, first, we don't like the cubed root. Instead, we write it as to the 1/3 power. Now we can clearly see an outside and an inside to be able to chain rule on this part of the problem. This plus 7x, this is something completely different. It's a different term. I'm not even going to worry about that right now. In fact, let's just ignore it. Pretend it's gone. It's not there. So the cubed root of ln of x, ln to the 1/3 power. Bring the outside exponent out in front. Your new exponent when you subtract 1. And then the inside stays the same. So this is the derivative of the outside with respect to the inside. I still need to multiply by derivative of the inside, which would be 1 over x. So there's your derivative outside with respect to inside, and then times derivative of the inside. Now, don't forget, we still had, though, this plus 7x that we needed to take its derivative. We can take it completely separately and put the plus 7 for its derivative right there. Maybe try to simplify this one a bit just to see how it would look. The ln to the negative 2/3 power would put it on the bottom. So ln of x to the positive 2/3 power. You also have a 3 on the bottom, and you also have an x on the bottom. So 1 over 3x, all that fun stuff, and then a plus 7 at the end still to deal with it. Okay, could be looking at that many different ways, but that's more than likely how it would be written for an answer. Okay, number 6 is a very common problem. And the reason being that this is a common problem that you're going to see is that I can rewrite this problem. Sine squared of x, you need to visualize this problem always as sine of x, the whole thing squared. That's what sine squared, or any trig function squared, means. That's just the way you have to formally write it. With doing that, now it's really easy for us to see what is on the outside and what is on the inside. And notice I still kept this ddx because I have rewritten the problem. I have not taken a derivative yet. So I can really easily see derivative of the outside, it's the exponent. So the 2 comes out in front. We keep the inside the same. Exponent's now down to 1. So that's derivative outside with respect to the inside. Now I need to multiply by derivative of the inside. The derivative of that inside is cosine of x. So that answer will be 2 times sine of x times cosine of x, because I can basically get rid of these parentheses and that 1 exponent. Just that simple. That's all it is. Now, one final one. We can pretty easily see an outside and an inside. That's good. The derivative of the outside, derivative of tangent, we got to know it, secant squared. Keep the inside the same, so e to the 2x plus 1. That's derivative outside with respect to the inside. That's great. Now we need to do derivative of the inside. So here's the derivative of the inside. Oh, wait a minute. Even with the derivative of the inside, we still have a chain rule. We still have something that is on the outside and the inside. Well, it's basically like you're starting a brand new problem. Think of one of those Chinese Russian dolls where you have Chinese Russian dolls. Listen to me. They're Russian something dolls where you have the doll, and then when you open it up, there's a smaller doll inside of it, and then there's a smaller doll inside of it. And you can keep on going forever and ever. That's basically all it is. Once you do this first, do I, it's like that tangent is now gone. Now you have a brand new problem for you to take a derivative of. What's the derivative of e? The derivative of e is just itself. That's derivative of the outside. Keep the inside the same, times derivative of the inside. So now I have just that, so my derivative of the inside would be then times 2. And again, they'd probably put the 2 out in front of everything in terms of getting an answer. So just for fun, I can make a real crazy long one. So let's say I have the square root of, let's do e to the sine of ln of x, no, let's not say x, let's say x cubed plus 1. So there's a big, long, nasty looking derivative that we can take. So what I'm going to first do is say I don't like the square root part, and instead of calling it the square root, I'm going to call it to the 1/2 power. When I take the derivative of the outside is 1/2. Your new thing will be to the negative 1/2, but we keep the inside the same. The inside is all this, e to the sine of ln of x cubed plus 1. So that's your first derivative of the outside with respect to the inside. When we do that, get rid of the outside. Well, the outside was this. That's gone. Now I have a brand new problem. How do I take the derivative of that? Well, the outside is e, which means the derivative of it is just the exact same thing. Derivative outside, keep the inside the same. And then I have to multiply by the derivative of the inside. Well, again, we did a do and an I, so I can get rid of my outside and start again. The outside function is sine of x. Derivative of the outside is cosine. Keep the inside the same. That gets rid of that. Now my derivative is of ln. My outside is ln. Derivative of the outside is 1 over, not just 1 over x, 1 over the entire inside. So that's derivative of outside, keeping the inside the same. That gets rid of that. And now I have just x cubed plus 1, all that's left, times 3x squared. So that whole big thing is what your derivative is. It's just one little step after another, like the Russian nesting dolls, just going one step at a time. We're going to do a lot more examples of these for sure, including where we may even throw in some product and quotient rule to go along with the chain rule. So stay tuned.